Okay, we're back, and now we've talked a little bit about covalent compounds. Now we're just going to talk about how do we name binary covalent compounds. And you might recall from our previous lesson that when we have a non-metal compound, we would name using something called the prefix system. If you go back to, I don't know if you did this, but if you go back to page 65, we drew this decision tree. And when we have non-metal bonded to non-metal, we have covalent bonding, and for that we use a prefix system. Okay, so on page 74 of your notes, I've just started a table there for you, and this is our prefixes. They're fairly simple, and you know probably some of them already. And we use Greek or Latin prefixes attached to the name of each atom, okay, to signify the number in each. So this is a really simple method if you get onto it. So if we have one of a type of atom, we would use the term mono. Now it's rarely put on the first element, or otherwise everything would almost be a mono. But you're probably familiar with carbon monoxide. And it's not monoxide, we would drop one of the O's for that one. So it's carbon monoxide, very dangerous gas that can take the place of oxygen in your hemoglobin, and it doesn't like to give it up, so you end up suffocating. Okay. Number two, again, you're probably very familiar with this. We wouldn't call this monocarbon dioxide, we would just call it carbon dioxide. Okay. And that works. So the di for two oxygens. Another nasty compound, sulfur, and we have three oxygens, so it's sulfur trioxide. And that's used to make sulfuric acid, so we don't want to run into that too much. If you inhaled that, you'd have sulfuric acid in your nose and lungs. This is four atoms would be, 4 is tetra, okay, and CCl4 would be carbon tetrachloride. Now, that's the inorganic name for it. It's sometimes known as tetrachloromethane, but carbon tetrachloride was a non-polar solvent used in the dry cleaning industry at one time, and it's rather carcinogenic, so you probably want to stay away from it. We don't have a lot in the lab. We have a little bit, but not a whole lot. Anyway, it sort of got into the water system at one time and was creating some problems. Now, do you know what is the symbol for 5? Well, that would be penta. And let's see, PCl5. So it would be phosphorus, pentachloride. Okay, so 5 is penta. 6 is hexa. Okay. Let's think now. SF6. Okay, so sulfur hexafluoride. Oops, fluoride. Okay. Now, from 7 to 10, we don't find a lot of compounds with those in it. I'll give you a few examples, but I'm just going to give you the prefixes for now. 7 is hepta. I know in Canada we want to say septa, but it's not. 8 is octa. 9 is nuna. And 10 is deca. Okay, so here's a compound that I used when I was in university. It was, let's see, what was it? It was P4O10. Okay, so we would name that. So the 4 pertains to the phosphorus, the 10 obviously to the oxygen. So I would say tetra phosphorus dec oxide. There's also a P2O5, so I just had a bit of a brain burp there. That would be diphosphorus pentoxide. And notice it's not pentaoxide, it's pentoxide. You drop the A from that kind of thing. So that's how the binary covalent compound works. It's a pretty simple system as well, as long as you know your prefixes. And so just study your prefixes and you'll be fine. Once again, if you can continue on, and now you should be able to do just about all the compounds. We're going to do acids and bases and acid salts at a later time, but I'll do that when I return to school later on. Thanks very much. We'll see you again. Bye-bye.